Good day everyone! In this video, we are going to talk about Heisenberg uncertainty principle. This is Leo Sinelio from Basic Science 3A. Heisenberg uncertainty principle is the basic idea is that based on the formula, we have here the delta P and multiplied by delta X. Delta P is the uncertainty in position. We have also here the delta X represents as the uncertainty of momentum, and the Planck's constant is represents as letter H divided by the 4 pi. As we all know, pi is equal to 3.14. So as we observe that position uncertainty is inversely proportional to its momentum. Therefore, the more we know about the object's or particle's position, the less we know about its momentum. But the more we know about its momentum, the less we know about the position of that particular object or particular particle. Alright. So here we are going to answer the problem number 1. It says here that a proton is confined to a region of having a width of 3.21 times 10 raised to the power of negative 11 meters. That is the uncertainty position, or represents as delta X. And we're going to estimate the minimum uncertainty in its momentum. So first, we are going to use this uncertainty equation, and having the given of delta X, that is the position we have here 3.21 times 10 raised to the power of negative 11 meters, and we have here the Planck's constant. As we all know that it is equal to 6.626 times 10 raised to the power of negative 34 joules per second, and we are going to find the momentum, change of momentum, or delta P. So we have here equation. So in order for us to find the delta P, so we are going to create or to make our own equation. So in order for us to remain this delta P, so we're going to divide both side by 1, divide 1 over delta X, 1 over delta X, in order to cancel out. Alright, so we have delta P remains. So we have here the delta P is more than or equal to H divided by 4 pi in the delta X. Now, let's substitute all the given values. H is equal to 6.626 times 10 raised to the power of negative 34 joules per second, or joules is equal to kilogram by meter squared. Alright, so we have here 4 and 4 just here. So the value of pi is 3.14, and we're going to plug in our delta X, the given, that is 3.21 times 10 raised to the power of negative 11. Now 4 times 3.14, that is 12.56 times 3.21 times 10 raised to the power of negative 11. So we have here the same units, so cancel out meter and meter. So we have here 12.56 times 3.21 times 10 raised to the power of negative 11, that is 4.03 times 10 raised to the power of negative 10. So divide, so we have here the total answer of 1.644 times 10 raised to the power of negative 24. So let's move on to our second problem, which is problem number 2. Let's move on to our second problem. It states that what is the uncertainty in the position of an electron given an uncertainty value of 0.20 meter per second in the velocity of the electron. So again, let's going to use our uncertainty principle equation and identifying the given. We have here given of velocity 0.20 meter per second, and as we all know that the mass of the electron, that is equal to 9.11 times 10 raised to the power of negative 31 kilogram. And our task is to find the delta x, or the change of position. So we have here now our equation. So in order to find our delta x, or the change of position, we're going to divide both sides by 1 divided by delta p, or the change in momentum. So we have also here 1 divided by change of momentum, so cancelled out change of momentum and change of momentum. So that is now, we have here the change, the delta x is more than or equal to the Planck's constant, represents as letter h, divided by 4 pi. Pi is 3.14, and the change of the momentum. So as we all know that in the non-relativistic momentum is equal to mass multiplied by velocity, but in the relativistic we have here mass multiplied by change of velocity. Now let's substitute all the given values. So given by the Planck's constant h, that is 6.626 times 10 raised to the power of negative 34 kilogram, or that is joules per second. So kilogram by meter squared per second. And copy the number 4, or the given 4 value, that the pi is equal to 3.14 multiplied by 9.11 times 10 raised to the power of negative 31 kilogram, that is our mass of the electron, and the change of velocity given as 0.20 meter per second. Now, cancelled out the same unit, we have here kilogram and kilogram, meters and meters, and second and seconds. So we have here meters remain. So we have here change of x is more than or equal to, or greater than or equal to 6.626, just copy. And we have here 3.14 times 9.11 times 10 raised to the power of negative 31 kilogram, 31 multiplied by 0.20, that is equal to 2.29 times 10 raised to the power of negative 30. So 6.626 times 10 raised to the power of negative 34 meters divided by 2.29 times 10 raised to the power of negative 30 is equal to 2.89 times 10 raised to the power of negative 4 meters, or that is 2.89.35 micrometer. Therefore, our delta x, or the change in position, is greater than or more than or equal to 2.89 times 10 raised to the power of negative 4 meters, or that is 289.35 in micrometer. So that's all. Thank you for watching, everyone.